everyone. So today we'll be discussing about a problem from Build Your Understanding of Pathfinder. This is from chapter Current Electricity. Let's get started. The problem states that the circuit shown consists of two capacitors of capacitance 1 microfarad and 2 microfarad respectively. There are also two resistors of resistances 10 kilo ohms and 3 kilo ohms, and there are two switches. Initially, the switches are in open position and the capacitors are charged to potential 4 volt and 6 volts, respectively according to the polarity they are shown. If both the switches are closed simultaneously, what is the amount of heat dissipated in the 10 kilo ohm and 3 kilo ohm resistors over a large amount of time, enough for complete discharge of the capacitors? Okay, so the key idea is in this problem we'll use some kind of jugaad, right? So let's get started. Okay, here's our circuit: 10 kilo ohms, 1 microfarad, 2 microfarad, 6 volt, 4 volt, and here's 3 kilo ohms. I assume these points to be A and B. So what will be the potential drop across A and B? VAB will be 4 plus 6, which is equal to 10 volt, positive 10 volt, which is equal to VA minus VB. It is plus minus, here it's plus and here it's minus, right? So the potential difference between A and B is 10 volts. So the current through A to B will be 10 volt by 10 kilo ohms, that is 1 milliamperes. Let me draw it another color. Here it will be 1 milliamperes, right? Now similarly consider the loop I am showing. Here the potential drop across the 3 kilo ohm is 6 volt. So here the current would be something 2 milliamperes. Here the current is 1 milliamperes and here the current is 2 milliamperes. By adding the currents we'll get here 3 milliamperes. Similarly, through the 1 microfarad capacitor 1 milliampere will pass, and through the 2 microfarad capacitor 3 milliamperes will pass. Now at time equals to 0, the charge on 1 microfarad is 4 microcoulombs, or you can write it as 4 times 10 to the power minus 3 millicoulombs. Similarly, charge on 2 microfarad is given at time equals to 0 is 12 times 10 to the power minus 3 millicoulombs. Now I am assuming a time of dt. So at time is equals to dt, the charge on 1 microfarad will be 4 times 10 to the power minus 3 plus the current through the 1 microfarad capacitor into dt. Already we know that the current through 1 microfarad is 1 milliamperes. So it will be 4 times 10 to the power minus 3 plus 1 times dt millicoulomb. Rather it will be minus because the current is going out of the positive plate. Similarly, charge in the 2 microfarad at t is equals to dt will be 12 times 10 to the power minus 3 minus what will be the current? Current is 3. So 3 times dt, which will be 4 times, which will be 3 times 4 into 10 to the power minus 3 minus 1 millicoulombs. One thing we can assure that the current ratio of charges through 1 microfarad upon ratio of upon 2 microfarad at time is equals to 0 or dt is 1 by third. Now you take time is equals to 2 dt, it will also be 1 by third. So at any time, for all time t belongs to 0 to infinity, the ratio is always equal to 1 by third. This is a very interesting conclusion we got it. Since the ratio of charges is constant, so we can also say that the ratio of currents are also constant. Ratio of currents is constant. So current through 10 kilo ohms upon current through 3 kilo ohms is equals to 1 by 2. So power through 10 kilo ohms upon power through 3 kilo ohms would be constant, that is equals to 1 by 2 whole square into ratio of resistance, that is 10 by 3, which when you will evaluate, so you will get 5 by 6. Total loss will just go in form of heat, which will be the energy of the capacitor initially stored, which will be equal to 1 times 1 by 2 times 1 times 10 to the power minus 6 into 4 square, that is the energy of the capacitor 1, plus half times 2 times 10 to the power minus 6 into 6 square, and if you evaluate it, you will get 44 microjoules. Although heat loss in 10 kilo ohms would be 5 divided by 5 plus 6 into 44, which will be equal to 20 microjoules. Similarly, in the other one, which is 3 kilo ohms, it will be 6 by 5 plus 6 into 44, that is equals to 24 microjoules, and hence we get our required answers. The main concept behind the problem is finding the ratio and proving that the ratio of the power dissipated will be constant. This can be proved by proving that the ratio of charges will be constant, or the ratio of currents will be constant, or the ratio of potential difference between the resistances will be constant. Anything is applicable, since just in any linear system, V equals to IR, and it's not a form V is equals to IR plus C. So if you change I by a factor of eta, so V will also change by a factor of eta. And in this case, it's generally applicable for non-linear systems. So I'm not going into that. Hope you enjoyed it, liked it. Thank you very much.